Hello and welcome back to Mr. Powers Teaches Algebra. Now we're finally getting into the complex numbers. I like complex numbers. I think they're lots of fun. And it's really neat. You know, we think of numbers, the real numbers, as numbers on a number line, right? Imagine here's a number line. You got your 0 here, you got 1 and 2 and 3 and so on. You got your negatives. And you got all the numbers in between these, whether they be fractions or they be irrational numbers like, root 2 right here, or maybe right here. We could say that's 1 plus root 2. Those are irrational numbers. Or we can have stuff like, right in here, whoops, right there. Let's say that's 7 halves, right? We could say 4 is here. So we got our fractions, we got stuff we can't write as fractions, all of that stuff, every number on the number line. But just so happens, it's not all the numbers. There are numbers, if we draw another axis here, so we got like an X, and we can treat this kind of like a Y. There's actually numbers that are not on the number line. They're hanging out above the number line, below the number line, below 0, above 0. We got numbers all over the place. And so what about those? And now I might be going about this the wrong way. Another way to look at this is to say, hey, we started in the caveman days with these numbers. They were like tallies. 1, 2, 3, 4, 5, 6. We counted those numbers. That's 6. And all those counting numbers we called natural numbers. Those were our natural numbers, and we got a fun little way to write those. N. All the counting numbers. Okay? And we can add 0 if we want, and then there's a name for those. We don't use that as much. I forget what it is. And then we have our integers where we can go negative. Okay, great. We got the negative numbers plus 0. And then and why did we need those negative numbers? Well, here's why. It's I think because there were numbers that we had trouble with, like we just couldn't figure out. Well, okay, it was subtraction, I think, right? We had addition, but then subtraction. It was like, well, what's 6 minus 8? What's that? And we're like, we need some other numbers. So we got our negative numbers. That's negative 2, right? And then we had division. We had multiplication. Okay, that works. We can go like 6 times negative 8. That works. We can get negative 48 now. So we got multiplication. We got addition, subtraction. What about division? What about that? So we can do like 6 divided by 3. That's 2. So that's still a natural number, an integer with the negatives, right? We could go negative 6 divided by 3. That's great. That's negative 2. But what about 5 divided by 3? Ooh, that we can't write as an integer, as a whole number. Whole numbers, that's the one. That's the natural numbers plus 0. We can't do that. So now what? Well, okay, now we got to say, okay, rationals, right? And those. So we can deal with these kinds of numbers. We have our rational numbers. Rational, which is this. We use a little Q for quotient. Weird looking Q. Okay? All right, so we got those. And then we had to have the real numbers. So like, well, what about stuff like what if we're taking square roots now, right? We can take square root of 4. That's 2. We can take square root of 9. That's 3, we can do those. But what about the square root of 2? Well, shoot. What about those numbers? There's no way to write the square root of 2 as a fraction, as a rational, because these are fractions of integers. We can't do that. Okay, so we need to find more numbers. So then we said, okay, these are irrational numbers, which I think is a weird I. I don't remember. Doesn't matter. Okay, so we got irrational numbers. Now there's one more thing we can't do. There's something we still can't do, and that's where I was going with, right? Now, all these numbers so far, rationals, irrationals, integers, natural numbers, are all on the number line. We got them all. That's it. It's everything. What isn't on the number line are these numbers here. How do we take the square root of -9? That's an operation now we still have trouble with if we don't know complex numbers. All these other things we can deal with now. Square root of 2, 5/3, -5/3, negative numbers. We can deal with that. We know how to deal with those. But what we don't know how to do is take the square root of a negative. Why don't negatives have a square root? There should be a way, right? And so we just say, we have this rule, a negative times a negative is a positive. But remember, those are numbers on the number line. So we need new numbers that aren't on the number line. And so what do? Well, we're going to use this little rule here. Remember that square root of AB is the same as the square root of A times the square root of B. And it just so happens that we can always take any square root and rewrite it as a product of -1. A product product that contains -1 as a factor. That's what I mean to say. So 9 times square root of -1. We could do that, right? Square root of 4. I could rewrite as, -4. I could write as square root of 4 times the square root of -1. We could do that. Okay, we can always do that, right? Because 1 divides everything, so -1 divides everything. So that's what I need then. I need a number, not on the number line, that I can square to get a negative. What's that number? That number is I. We're going to call it I. And so don't get confused on this little. That's probably good. Okay. It's I. Got to fix that. So I, is going to be the square root of -1. All right. Therefore, this is a very important property of I, is that I squared equals -1. It is the only number that's squared to get a negative. Is the I. Okay. So, and it's -1. So now, what is -9? Or the square root of -9. What is it? It's actually, square root of 9 is 3, and square root of -1 is I. It will be 3I. What is the square root of -4? It will be, square root of 4 is 2. Square root of -1 is I. Ooh, now I can start taking square roots and negatives. Yes, just like we now can do fractions and we can do irrational numbers. We can deal with pi, square root of 2, and weird stuff like that. Now we can do roots and negatives. Now we can do everything. And if you were wondering, is there another thing we can't do? No, this is all the numbers. We got them all. This is it. There's no more. There's a way to show it. I don't remember how. But we can show that this is it. There's no more numbers, so don't worry. How do you check if 3I is really the square root of -9? You would square it, right? 3I squared. What does it equal? It equals 3 squared times I squared. And what is 3 squared? It's 9. I squared is -1. So 9 times -1 is -9. So yes, now we can take square roots of negative numbers. That is really, really cool. And so I'm going to end this video. We call numbers like this, 2I, 3I, I. We say imaginary numbers. And don't get it mixed up. It is a label. Just like real numbers is a label. Imaginary numbers. Okay? It's a label. They are real numbers. They're actual numbers. Okay? It's just the name we gave them. Maybe a poor choice in names, but name nonetheless. Okay, so we got one more thing to define, and I think I'll be really lazy about it. And I'm just going to there we go. I'm just going to go ahead and copy and paste. So let's see here. There we go. All right. So the standard form of a complex number, okay? So here it is a plus bi. These are complex numbers, a plus bi. The first part is it's okay. So a is a real number, and we say that's the real part of a complex number. Okay? The real part. And then the bi is our imaginary part. A and B can both be real. Okay, so just like before, you remember I went up here to the number line, I had root 2 and I had 1 plus root 2. You could almost think of it analogous to that you got, for irrational numbers, you got the irrational part, and you can have the rational part. You could break it up, 1 plus root 2. That is an irrational number, but it has a real part, or it has a rational part and an irrational part. So like this, what if you had 3i as a number? Well, what do you get when you have 2 plus 3i? Well, that's still going to be an imaginary, no, not imaginary, it's going to be a complex number still, right? Because it's still a number that's not on the number line. This is definitely not on the number line. Okay? So I think that will do it for today. And then I just want to show you some examples of complex numbers, and then we will start playing around with these. So these are examples of complex numbers. All of these work. 3 plus 5i, root 6 minus 10i, 4/5 plus I, 16i, 113 as a number. Why is that a complex number? Because you could rewrite that as 113 plus 0i. You got your real part, you got your imaginary part. 0 times anything is still 0. All the rules we have for real numbers still apply. So like distribution, rules for adding, subtracting, multiplying, dividing. So pretty much you can treat the I like an X. And like, so 5i plus 3i is 8i. Just like 5x plus 3x equals 8x. Because the reason we could do that is because of distribution, and we still have those rules. All those still work perfectly well with these. So that's why we can still just treat them like that. So they're really not that tricky. But now we can handle things we couldn't handle before. So that's enough. That's our introduction to complex numbers. The big takeaway is a plus bi is the form of a complex number. These are examples here. And I is the square root of -1. I squared is -1. That's the thing you got to remember. And the most important thing is that I squared equals -1. That's why it actually goes that way. And then backwards, since I squared equals -1, square root of I must be -1. Okay? All right, so that's all I got. Until next time, enjoy doing math.